All right, so last week we went over 1-3 questions out of your homework, and we covered 1-4 in that video lecture. So hopefully you've caught up with things. What questions might we have out of 1-4 to look at? We've got plenty of time to set some of these up if we need to. Which ones would you like me to set up for you? Okay, question 4. Let's see. Other questions. Anything else? I'll go ahead and set up 9 and 10. I won't work them out completely just to make sure we know how those distance problems work. And maybe 11 as well. Those are sometimes difficult to set up. What about the angle questions? And the angle questions are 13 through 16. Are there any of those that you'd like me to work out and set up? Any of those? What about the consecutive integer problems? Do we need to look at any of those? That's going to be 17 through 20. Are there any of those that you'd like me to look at? I'll add one just to make sure we know how to set these up. So I'll add in 19. Okay, let's go ahead and get started. Now we can add more if we need to. So these are just kind of a start for us. If you want to see any of the questions that we looked at out of 1-3, I think all of them now are pretty much set up. You can look at that video and see how I set them up. So if you need to, look in Blackboard or your email. You'll see that video link. You can watch the 2 videos. There's one where we covered 1-3, questions from our homework. I tried to cover a lot of those. And we also went through 1-4. Anything else? Well, we'll go ahead and get started with these then. So we're going to look now at question 4 out of 1-4. Okay, so this one is kind of like a mixture in an investment problem. Now we're looking at 2 types of money, 2 types of bills. Okay, and let's see. Josephina? Yep. Working on trying to get everyone's names down here, so I think I've got everyone marked off so far. Okay, so we're going to look now at question 4. Now this is a money question. So we're going to read it. We're going to identify what we're looking at. Set up the equation, and then I will leave the equation for you to solve. So a convention manager finds that she has $1,290 made up of 20s and 50s. She has a total of 42 bills. And we want to know how many $50 bills that we have. Now, since we're looking for the $50 bills, I'm going to try and call that one X. So we'll do that one first. That way we don't have to rework it again at the end. Now, what do we have? We've got the number of bills, and we've got the value of those bills. So when we look at our total value, that's going to be the number of bills times the value of those bills. So each of these are like your investment questions, except instead of amount of money, we've got number of bills and the value of the bills. And we've got bills that are $50, and we've got some bills that are $20. I'm going to call the $50 bills X because that's what we want to find. Now, how many total bills do we have? Remember, on the right-hand side, we've got a total number of bills, not the value, the total number of bills. Well, if we read the question here, it says that we have a total of 42 bills, right? The $12.90 is not going here. $12.90 is the value. We're first looking at the bills and how much they're worth, or the value of each bill. Now, if I know that the first one is X, we don't know how many $20 bills that we have. So how do we handle that? Well, that's going to be your total minus X. And how many total bills do we have? We have 42 bills, so that's going to be 42 minus X there. So that's what we've got so far. Now, what do we need to do? We need to look at our total value. And how do we find our total value? Well, the total value, you can call it worth. I just call it value. But my total value of each type of bill is going to be the number of bills times the value of each bill. And this one will be number 1. This one will be number 2. So what do we know about the first one? Well, the value of the bills is 50. Number of bills is X. So my first one is going to be 50X. Bills times the value. Now, what about the second one? Well, what's going to happen with it? How many bills do we have? We have 42 minus X for the number of bills, because that's the total minus X. And how much are those bills worth? They're worth $20 a piece. And what's the total value of all the bills put together? That's given in the question to be now that $12.90. So that's what we've got for our equation there. I'm not going to finish it all for you, but you can finish it. Now we want the number of 50s. So when we solve this out, we'll get the value of X. Okay, and X is going to be the number of $50 bills. I set the 50s as X because that's what we want to find. It'll just save us a step. You could do it the other way with the 20s first, but in this case, since we want to find the number of 50s, it's going to be easier if we make it X here. So you can finish this one on your own. And that's just going to be distributing through and combining like terms. But there is your equation. Is everyone okay with how I set that one up there? Very, very similar to the investment and the mixture questions. 9 is a distance problem. And when we talk about the distance problems, there's 3 different scenarios that we can encounter. They can add together, they can subtract from each other if they overlap, and they can also equal each other. So I'm going to set up question number 9. So let's read it, draw our diagram, and then work with our distance here. So we're looking at a point on the river. So from a point on the river, 2 boats are driven in opposite directions. One's at 5, the other's at 7. In how many hours will they be 36 miles apart? So first, draw our diagram. So we're going to start right here in the middle of this river. They're going in opposite directions. So we'll say one is going east, one is going west. Now, when we talk about distance, what do we have? We have 3 basic components when we drive our car. We've got miles per hour. We've got how many minutes or hours it takes us to reach our destination. And then we've got how many miles we drove. And the distance is going to be the rate times the time. So that's going to be very, very similar to our total value that we did a moment ago. So what do we know about these boats here? They're going in opposite directions. So if they go in opposite directions, what does that mean? That means they add. When do they subtract? When they overlap. Do these overlap at all? Do they cross over each other? No. So that means this one's going to be what? This one's going to be addition. Now, what do we know about our rates of speed? Well, our rates of speed, we've got 5 miles per hour and 7. So the first one is going to have a rate of 5. The second one has a rate of 7. What we do not know here is we do not know the times. So that's going to be the unknown. And you can use either a t or an x. Doesn't matter. I'm just going to use an x because that's what we're used to working with. So we know they're going to add together because they do not overlap. So this will be 1 and this will be 2. Now, what are we trying to find? We're trying to find our distance. So how do we find the distance? Well, the distance is what? Distance is the rate times the time. So distance is rate times time. So what do we know on our first one? Our first one, rate of speed is 5, time is x. So that's going to be 5x here. What about the second one? These are going to add together. So that's going to be 7x, and then we need our total distance. And what's my total distance here? It gives this in the question. It gives you that these are 36 miles apart. And you should be able to finish this one without a lot of work from there. But do you see how I set up the question? Now, why are these adding? Okay, these are adding. Oh, is that door locked for some reason? Oh, thank you. Yeah, that door must have locked. Sorry about that, Tracy. Okay. Sometimes that door wants to lock on its own, even though it's unlocked. So this is what we've got here. Now, you should be able to finish it by simply adding and dividing. When you find x, that is going to be the time that you want. And we're just looking at questions out of 1.4 here. So that was question 9. Just to make sure we know how to set these up, I'm also going to look at 10. So question 10 is a little bit different. Question 10 talks about the stream, the speed of the stream. Now, what do we know about the wind or a stream? Well, the wind and the stream can either add to your speed or decrease from it. Because there's what's called a terminal velocity. There's a maximum speed that an airplane can go. Now, it might be able to go a little bit faster if the wind is pushing it along, or it might be a little bit slower. There's a speed at which it can go for its maximum. And same thing with a boat. The stream or the wind can either add to it or it can subtract from it. The speed of a stream is 6 miles per hour. If a boat travels 80 miles downstream in the same time that it takes to travel 40 miles upstream, what is the speed of the boat in still water? So this one is a little bit different. That's why I wanted to make sure that we went over this one. Well, first things first, what do we know? We know we've got a stream and we've got a boat here. So they're going in opposite directions like that. And then we have the stream that's either going to add to it or subtract from it. And that stream has a rate of speed on question 10 that is 6. We don't know x, so we're going to call the x the boat speed. So that's going to be the fastest this boat can travel. Now, again, it might go a little bit faster if it's going with the stream, or a little bit slower if it's going against. So I'll go ahead and draw the stream arrows here. By the way, these are going to be equal, but it's a little bit different because the distances are going to be equal. So let's talk about what we know. So we're going to go through all the different pieces here for the setup. A boat travels 80 miles downstream. So that would be this one down here. Because that water is making it go faster. It's going in the same direction as our distance. In the same time, that's very important here, that it takes to travel 40 miles upstream. So my distance upstream is going to be 40. Now, we always need to figure out two components so we can get the third. So what do we know now that's given? We don't know the speed of the boat, right? So that's unknown there. But what do we know about the stream? Well, it's 6, so it's either going to add to it or subtract from it. So let's talk about a rate of speed here. Now, what do we know about the stream? Okay, the boat's going in this direction. The stream's going in the opposite direction. So that means it's going to be subtraction, right? Because it's going the opposite direction. It's holding that boat back. Now, what about the other one? When we're going back, we're going downstream. So what do we know about its rate of speed? Does anyone want to tell me what that one would be? That rate of speed would be what? Okay, this one was x minus 6 because it's forcing it back. What about this one when it's going the same direction? Okay, x plus 6 then. Is everyone okay with how I got that? Now again, we need these three components: rate, time, and distance. What we are missing and what we have not talked about is the time. And we know that the time must be the same. Now, normally we get our distance by taking the rate times the time. But we don't want to work with the distance anymore. We want to find our time because the time has to be the same. So what do we know? We know our distance d equals the rate times the time. Again, we want the time. So let's solve this for the t. We can solve this for the t by dividing by the r. So that tells me then that my t, my time, is going to be the distance over the rate of speed. So in terms of words, this is going to be our time, is going to then equal our distance over our rate of speed. So it is a little bit different, and that's why I wanted to make sure that we covered this one in the homework. So we've got it all set up. And how would we finish it out? Well, let's see what we've got. Okay, we need to find our time and the distance and rate for each one of these. So I'm going to call this one 1 and this one 2. And we know that they're going to be what? We know that they're going to be equal, right? So we know these are going to be equal to each other when it comes to the time. So let's now try to build our equation. And again, we're using division. So on our first one, we want to look at our time. What is our time? Distance divided by the what? Rate of speed. So on our first one, what's our distance here? Our distance is going to be 40. And what's our rate of speed? That's here. And that's going to be x minus 6. What is that going to equal for our second component, or our second one? Well, on the return trip, when we go downstream, that speed is 80, that distance is 80, and the rate is x plus 6. Bring this in a little bit more so we can see it a little bit clearer here. So this is what we've got. Now, I am going to go ahead and finish this one out just so we know how to handle an equation like this in the future. So if I gave you this has fractions in it, how would we clear the fractions? Well, we can use cross multiplication. We can cross multiply, and that's going to clear out our fractions. So when I cross multiply here, that's going to get rid of these fractions, and that's going to then give us 40 times x plus 6 equals 80 times x minus 6. Now, when we solve this out, we're going to find x. And again, what was x? X was the speed of that boat. And that is what we want in this question. It says, what is the speed of the boat? X represents the boat. So I'll go ahead and finish this one out. So we cross multiplied. Now we're going to go ahead and distribute through. And then we'll simply solve this equation out. So we've got 40x here, plus we've got 40 times 6, I believe that's 240. That equals then 80x minus 480, I believe. Minus a 480. So there's our equation. We got that by cross multiplying. Now we simply solve it. So move things around. We're going to move that 80x over with subtraction. And then we're going to move that 240 over as well. Then that gives me 40 minus 80. Well, that's a minus 40x. The 240s, one's positive, one's negative, so they clear out. The 80x, they cancel as well. And then we've got 480 and a 240. They're both negative, so we'll add together. Give you a minus 720. Then we'll divide by our negative 40, and that's going to be our final answer. It does come out to be positive. And when we divide, we get 18. And what is that 18? That's the speed of the boat. And that is going to be in miles per hour. So that one was a little bit different, and that's why I wanted to make sure that we covered it. And how was it different? We weren't looking at the distances, we were looking at the what? Times. So we had to manipulate our formula around a bit, because time is division, because time is your distance divided by the rate. We worked it out, and we got that 18. And that 18 is the speed of that boat. We're going to look at one more distance problem. And then if we need to, we can look at some angle questions and also some consecutive integers. So we're now going to look at question 11. And it is similar to question 10. So question 11. A plane flies 400 miles with the wind and 300 miles against the wind in the same length of time. So very, very important. Same length of time. So it's going to be set up almost exactly as the last one. The speed of the wind is 20 miles an hour. And what is the speed of the airplane? Okay, so we're going to go through and draw our diagrams again. One's going with, one's going against the wind. The wind is going to go in this direction. Doesn't matter which way. It's just that one's adding and one's subtracting. This wind is 20. X is going to represent the speed of that plane in still air. So that's the speed of the airplane with no wind. And we know these are going to equal. Now, what's going to equal again? Times, right? Because it says same time. Very, very careful with the wording. It says the same time. What do we know about the first one here? Okay, this is going against the wind. So when it goes against the wind is going to push it back. It travels less, and so it's going to travel the 300 here. Now the rate of speed is slower, so it's going to be x, in this case, minus 20, because the wind is going to force it back a bit. When we fly back, the distance is added to it from the wind, so that's going to be 400, and its rate of speed is x plus 20. So that is what we have so far. We've got 1 plus and 1 minus. Now we know that the times are the same. And how do we find our time? Well, the time, we just did this a moment ago, is the distance divided by the rate of speed. I'm not going to solve this one completely out, but I will get you to the equation, and I will clear the fractions. So this will be 1, and this will be 2. Let's go back up and look at our first one. Okay, the distance is going to be 300. Rate of speed is x minus 20. That's going to equal our second one, which is that 400 over x plus 20. How do we clear these fractions again? Well, one technique that we can use is called cross multiplication. When a fraction equals another fraction, we can cross multiply. So we will cross multiply these, and we get 300 times x plus 20 equals 400 times x minus 20. And you can finish it from here. So you distribute that 300 through, distribute that 400 through, and solve it out. Just like the last one. And this is 1, and this is going to be 2 over here. I like to label everything so we can keep track of it all. Does anyone want me to work through any of the angle questions? Any of them from 13 through 16? Are there any of those that you'd like for me to look at? I think those are a little bit easier. Any of those, 13 through 16. And remember, you can go online and look at the notes from last week. Normally we don't, when we cancel class, I don't do a lecture. But again, this class we've missed so many times that we really, really need to get caught up. Sure, we can look at 14. So let's talk now about 14. Now, when I give you an angle question, there are 3 different outcomes that we can have happen. First off, we can have what are called complementary angles, which is like this. Complementary angles, these sum to 90 degrees. Supplementary angles look like this. So they form a straight line, and these sum to 180 degrees. So one sums to 90, one sums to 180. And then we can also have what are called vertical angles, and they make an X. And when we look at vertical angles, the left equals the right, and the top angle equals the bottom angle. So these are our 3 different scenarios here. Also on these, when we solve it and we get X, now X is not going to be our final answer. What we want for our final answer is we find that value and we plug it back in. And we get the 2 angles in this case. So which one does this look like? Well, this looks like what's called complementary. So complementary, they make a right angle, and so it sums to what? 90, doesn't it? Okay, if it makes a straight angle, it sums to 180. This one looks like this one, so it sums to 90. So we then know that 4n plus 14n minus 72 is going to now equal 90. So that's our equation. So what can we do? Well, these 2 n's can go together, and that makes it 18n because they're the same. We can add 72 to each side, moving that over, and that leaves me now with 90 plus 72, which is 162. And that equals our 18x, or sorry, in this case, n, 18n. So we'll divide both sides by your 18. And that leaves us with n then equaling 9, it looks like. Now again, that is not my finished answer. What you have is you have part of it. We got the 9. How do we get the actual answers? Well, to get the actual answers, we're going to have to take that n equals 9, and we're going to have to plug it back in to the 2 angles. So let's go ahead now and plug that 9 in. So my 2 angles, redrawing them again, are that 4n and 14n minus 72. So 4n, well, that's going to be 4 times 9, which is my 36 degrees there. So that's our first component. Now, what about the other one? What is it going to be? It's going to be 14 times 9 minus your 72. And 14 times 9, that's 126. Minus that 72 gives you then what? Gives you then 54 for the difference. So what are our answers now? What do I expect to see in your homework? Well, your answers would be then 36 degrees and 54 degrees. Now, how do I know that I did it correctly? Well, I know that I did it correctly. How? These should add up to give you what? 90. Do they add up to give you 90? Yes, they do. So we know we then did it correctly. But do not just stop at the n. You've got to plug that value of n or x back in and get the two answers. Any more of the angle questions? That take care of those, because there's complementary, supplementary. There's also a triangle one. What do we know about a triangle? Triangles sum to what? 180. So add them all up, get your 180, and then plug your values back in. Well, if we don't have any more of those, then we'll look at the consecutive integer problems. We'll look at 19, and we can add more of these if we need to. So let's kind of review quickly consecutive integers. Now, what are consecutive integers? Well, consecutive integers are back-to-back numbers. Okay, that's your basic definition of consecutive integers. We can also have even or odd. So let's talk right now about consecutive integers by themselves, and then we'll talk about even and odd. So consecutive integers, that would be things like 2, 3, 4, 5, 6, and so on. Now the gap between each number is 1. So the gap between them is always 1 for these consecutive integers. We always begin with our first number being x, and then we add 1 each time. So my second one would be x plus 1. My third one would be x plus 2. And my fourth one would be x plus 3. Now, also, we might have, like in question 19, even or odd. So even or odd consecutive integers. Well, what do even or odd consecutive integers look like? Even or odd would be things like 3, 5, 7, 9, 11, or it might be something like 4, 6, 8, 10, and 12. And what do you notice about these? These have a gap of 2. Okay, so the gap's either 1 or the gap is 2. Now, how does it work if we have a gap of 2? Well, if we have a gap of 2, that means we call our first number x again. Second one is x plus 2. Third one is x plus 4. And our fourth one would be x plus 6. Because you're adding what every time? You're adding 2. So if it's just consecutive integers, what do we add? 1. Okay? If it's even or odd, how much do we have to add? 2 each time. So we've talked about these consecutive integers now. Let's look at question 19. We can add more of these questions if we need to, but let's just begin with question 19. If the first and the third of 3 consecutive, here's an important word here, odd integers are added together, the result is 75 less than 5 times the second integer. Find the third. I'm going to go ahead and find all three, and then we'll just box the one that we need. So when I first read this question, let's take a moment to think about what we've got. What type of integers are these? Odd. So what's my gap going to be? 2. How many of them do we need? 3. So let's start with that. So our first one, no matter what, we call that x. Our second one, we're going to call that one, since it's odd, these are odd, that's going to be x plus 2. And our third one, well, that's going to be x plus 4. So we've got our 3 consecutive integers that are odd. 3 consecutive odd integers. So it says if the first and the third of 3 consecutive odd integers are added together. So first and third are added together. So that's going to be number 1 plus number 3. The result is, that means equals, 75 less. Okay, so that's going to make it subtraction here. So we've got our 75. We're going to have to take it away. And what are we going to have to take that away from? 5 times our second integer. So we've got the first and the third summed together. Result, that means is 75 less, so it's being subtracted off. And that's from 5 times the second integer. So let's go ahead and fill it in. We know our first one is x. Our third one is x plus 4. Then we've got 5 times our second one, which is x plus 2. And then we've got a minus 75. Okay. Go ahead and distribute that 5 through. Combine like terms on the left. So these x's can go together. So on the left, we've got 2x plus 4. Distributing through, we've got 5x plus 10 minus 75. So I just distributed that 5 through. We can now combine these together. And so we now have 5x minus 65 equals 2x plus 4. Move things around. So move that 5x over with subtraction. And move that 4 over as well. And that leaves me then with a minus 3x. The 4's can cancel. The 5x's can cancel. And then we've got 65 minus 4. They're both negative, so it stays a negative 69. We'll divide by our negative 3. Negative over negative makes it then a positive 33, it looks like. Now, that is not my answer. Let's go ahead and get all 3 of them, and then we'll get the third integer. Okay, so let's go ahead and get all 3. So my first number is x, so that's 33. My second number, add 2 to that, is 35. And my third number is 37. We want the third number. Did I make a mistake here? Oh, sorry about that. Did I make a mistake? Yep, I should have been more careful. Probably wasn't thinking here. Let's double check, make sure I didn't make a math there. Should be 23. You're right. My mistake. I just wrote down an extra 3 there. So it'll be 23. Sorry about that. 25 and 27. Right? Okay. So we want the third number. And what's our third number? Our third number is now what? 27. So your answer for this question would then be 27. Is everyone okay with how I work that one out? Does everyone see how I set it up? And again, you can look at the video that I posted as well, where we went through a lot of these. Are there any others to look at? Out of 17 through 20, any more of those? Do those kind of make sense now? And just to make sure, on question 18, when it says 2 pages that face each other in your textbook, what is that? Okay, when we talk about 2 pages that face each other, that's like these 2 pages. So these are going to be just consecutive integers, right? So when it says 2 pages in the textbook face each other, that is just consecutive integers. So that's going to be adding 1. And that's for question 18. So question 18 will be adding 1 because they're just 2 pages in the textbook. And same thing with question 20. Adding 1 each time. Well, then if we don't have any other questions, then we'll talk a little bit about 1.5, and then we'll take a really short break, come back, and finish up 1.5. We're just going to take a few moments to quickly talk about the very beginnings of 1.5. And this is a much, much easier section to work through than 1.4. 1.5 is all about inequalities. So let's just review a little bit about inequalities and how to graph these. For inequalities, if we have greater than or we have less than, those are going to get parentheses. When we look at greater than or equal to, less than or equal to, those are going to get square brackets. Also, positive or negative infinity always gets parentheses. We're just going to learn how to graph a few of these and write them in interval notation. Once we've seen how to do that, we'll take a break, we'll come back, and we'll learn how to solve these inequalities. So let's just do a couple of these. We're just going to graph them and write our answer in interval notation. All right, so I want you to graph this one. Always make sure your x is on the left-hand side, so it needs to be on the left by itself to graph these. So as long as my x is on the left, then I can look and I can see which way does it point. Okay, this inequality points to the right. See how it points to the right here? So we're going to draw our number line. We're going to find our -5. So we just put down a -5 somewhere. And which way is it going? Well, if we look, it's pointing to the right here. So that means we're going to have to graph to the right. So whichever way it points is the way it goes. Now, what about that greater than or equal to? Well, that greater than or equal to, that's going to get a square bracket. Why does it get a square bracket? Because it's greater than or equal to, right? Those get square brackets. Strictly less than, strictly greater than, they get parentheses. Also remember on the number line, negative infinity is to the left, positive infinity is to the right. how would I write this now in interval notation? Well, in interval notation, it comes directly from the graph. Some textbooks use open and closed circles. I don't. I think the brackets and the parentheses are easier because they go right into interval notation. So in interval notation, directly from the graph, we've got -5, comma, where does it go to? Positive infinity. And what does infinity always, no matter what, have? Parentheses. So you just look at which way it points, shade in that direction, and then write your answer directly off of that number line. So that's how we graph that one. Let's do another one. We'll do 3 of these, and then we'll take a short break. What about this one? What about x is, let's say, strictly less than 10? How would I graph this one? Well, I come down and I look at my question. My x is on the left. X needs to be on the left for this to work. Which way is it pointing? It's pointing to the left, right? That's the way it's pointing. So that's the way where we shade. So we find our 10 on our number line, and we shade back to the left. Now, what about 10? It's less than, so that means we have to use parentheses there. And where does it go to? Label your infinities. You've got negative infinity back to the left, positive infinity to the right. So where does this go? It goes back to negative infinity. Now make sure you write them in the order they are on the number line. So parentheses negative infinity is first because that's on the left, so don't mix up the order. Where does it stop at? It stops at 10. But very, very important that you keep the order. Do not mix them up. A negative infinity is always on the left. Positive infinity is always on the right. We'll look at one more. This one's going to be a double inequality, or as the textbook calls it, 3-part inequality. And how would we graph this one? Okay. Well, what is this saying? Okay, this is basically saying that x is going to be what? X is going to be trapped between -10 and 4. So we come down to our number line. -10 is on the left. +4 is on the right. We want it to be trapped in between them because it's in between those two numbers. So that means we're going to shade in the middle. The -10 gets square brackets. The +4 gets parentheses. So what does my answer now look like? Well, it looks like square bracket -10. And where does it go to? 4 with parentheses there. So it just comes directly off the number line in the same order. We're now going to go ahead and take a short break, and then we'll come back and we'll finish up 1.5. So let's meet back here at 9:35. So meet back here in about 10 minutes at 9:35.